Let's look at an example of a trigonometric integral. Say that we want to find the integral of secant cube theta d theta. So one way that we can proceed with this one is to separate the cube as a square and a simple secant. In other words, we can write this down as secant squared theta times secant theta d theta. Now this is a common trick to split powers in order to reduce them. One of the things that we can notice in here is that secant squared is the derivative of tangent. This is a very important property that we can use. So in order to use this, we can think about following the integration by parts technique. In other words, we can say the integral of u dv is equal to uv minus the integral of v du. In this case, since I noticed that secant squared is the derivative of something, this is the natural candidate for the dv. Then I can do secant to be my u, and I can apply the integration by parts formula. So in this case, I would get u equals secant theta, and then dv equals secant squared theta d theta. This will give me du, which is the derivative of secant, to be secant theta tangent theta d theta, and v, as we said, that is just tangent theta. So applying the integration by parts technique, this will give me u times v, which is secant theta times tangent theta minus the integral of v du. The integral of v du would be tangent theta secant theta squared. So what we can do now is we can apply a trig identity for this one. In other words, if you remember, we have several trig identities from the Pythagorean identities, and one of those is 1 plus tangent squared equals secant squared theta. So in this case, from here, we find that tangent squared is nothing else but secant squared theta minus 1. So let's use this substitution. Here we would have that our integral is secant theta times tangent theta minus the integral, now using the identity, would become secant squared theta minus 1 times secant theta d theta. So let me just simplify this a little bit. This will become secant theta times tangent theta minus the integral of, and we can distribute this, secant cube theta minus secant theta d theta. So it seems that we really have done nothing, because if you check, we have again the original integral that we have. But that actually is not entirely bad. We can split this into parts, and this will turn out to be very convenient. So we have this to be the integral of secant theta cube d theta plus the integral of secant theta d theta. Now let me write down again everything that we have so far, because so far we were able to rewrite our original integral secant cube d theta as secant theta tangent theta minus the integral of secant theta d theta plus the integral of secant theta d theta. Now notice that this part right here is the same thing that we have on the left hand side. In other words, we have pretty much the following thing. We have something we're trying to look for equals to one expression minus the same thing we're trying to look for plus another expression. And notice that this expression, the last one, the integral of secant, that is a common integral. So we can just find the antiderivative of that by looking at a table. That means that if I want to solve for this unknown, which is the integral of secant cube, I can just write down 2 times that unknown to be the first part plus the second part. In other words, this is the first part, and this is the second part. So in other words, what we're doing is we're literally solving for the integral. We can move this integral to the other side, and then we will have twice the value of the unknown equal to the expression that we computed. So this becomes 2 times the integral of secant cubed theta d theta equals secant theta tangent theta plus the integral of secant theta d theta. Now again, this integral, we can find it in a table of integrals. So we can just substitute for that. This will become 2 times integral secant cubed theta d theta equals secant theta tangent theta plus the natural log of secant theta plus tangent theta plus a constant. So in order to finish this, we just have to divide by 2. And then we will get that the integral of secant cubed theta d theta equals 1/2 of the expression that we just wrote. Secant theta tangent theta plus the natural log of secant theta plus tangent theta plus a constant. So notice that what we did in here was to combine integration by parts with trigonometric identities, and then just following everything would lead me to the answer.